Alright, so let's talk about indefinite integrals for a second here and do an example video with an example problem. I'm just going to use a pretty simple third-degree polynomial here for us to evaluate the indefinite integral of. Now, I've got a video on indefinite versus definite integrals that goes in depth explaining the difference between those two, so if you're a little bit shaky on the conceptual difference between indefinite versus definite integrals, what we use each for, then go ahead and check that out. It's going to be on this Calc 1 integrals playlist on my channel. So, a quick recap of indefinite here. Indefinite integrals they don't care about an interval at all. You're just going to have the integrand is not going to be over a certain interval, so you're just going to have the indefinite integral of some function dx, and it's going to give you another function, okay? That's basically what's going to happen with this. Another way to think about the indefinite integral is just the antiderivative. And you know that the antiderivative, of course, is if you have a function, let's say f of x, what function, when you take the derivative of it, gives you f of x. So, in this case, the antiderivative of, let's say, 2x is x squared because x squared prime equals 2x. Okay, so really we're just talking about, let's take the antiderivative of something. Alright, cool. Let's go ahead and look here. Let's take the antiderivative of, or the indefinite integral of 1 plus 2x minus 4x cubed dx. So this is what we're interested in right here. Alright, so just like a lot of other things in math, breaking this up is going to be a really, really good thing to do. So let's break up this problem. And it's totally legal and cool for us to do that. We can do it with no problem. So let's break apart each part of this sum, or each part of this little expression. So let's have the indefinite integral of 1 dx plus the indefinite integral of 2x dx minus the indefinite integral of 4x cubed dx. Now, this is exactly the same as this function. They mean exactly the same thing. All I've done is broken it up a little bit, made it a little more easier for us. So, if we just remember that this is our parent, then we're good to go. And this is just another version of it, this piece right here. So, alright, cool. Now that we've broken it up, let's just attack these pieces individually, okay? So, the indefinite integral of 1, well, that's just simply saying, what's the antiderivative of 1? So, what function, when I take its derivative, is going to give me 1? Well, x is, right? So x prime is always just going to be 1. So if we're, because this is dx, because we're evaluating with respect to x, like dx of x, yeah, this is totally 1, but hang on, this is going to be where that watermark is, but dy of x is not 1, right? dy of x is not equal to 1 because we're evaluating at y. So it's of course important that we remember that if we have to be taking dx for this to count. So, all right, but we are, so all is well here. So this, of course, the antiderivative we said is x, so we just have x here. We're good to go. X plus, all right, the antiderivative of 2x. All right, well, if we remember, we have this cool little rule we can use that says when we have something to the nth power, because remember, 2x is the same thing as 2x to the first power, right? Anything is itself to the first power here. So we're going to use this little exponent rule that says x, still on my eraser here, that says x to the nth power is just equal to the indefinite integral of x to the nth power. We got to write this correctly. Yeah, x to the nth power. Drat. I'm sorry, guys. X to the nth power dx is equal to x to the n minus 1 over n minus 1. So this is crazy helpful for us. So we can, by that logic, take 2x dx, bring it down, and all it is 2x squared, right? X to the n minus 1. I keep saying n minus 1 in these videos. N plus 1. So we're going to have, I'm getting ahead of myself, so we have 2x squared here. And then it's going to just be over 2, n plus 1. 1 plus 1 is 2. So x plus 2x squared. So we've taken care of this. We've taken care of this. Now let's work on this here. What is this going to be? So negative minus 4x cubed. Well, hey, let's just use this same rule again. Why can't we? So x to the n plus 1. We're going to have our 4 here. This constant is going to stay the same. So we have 4x to the 4th. Over, well, n plus 1, 3 plus 1, just 4. So let's make this parenthesis look a little more appropriate to the size of this entire function. Great. So now we have this, and this is not complete, because what do we need to do? Well, we always have to add plus c, right? Because think about it this way. What is the derivative of, let's just do another little page here. What is the derivative of x squared? Let me ask you this. Now you know the derivative of x squared is 2x. But what if I say, okay, well, great, we know the derivative of x squared is 2x. What is the derivative of x squared plus 1 prime? Or x squared minus 7,386.2957001. Repeating. What is this prime? Well, it's the sum rule here, and it's the difference rule here. So we know it's the derivative of x squared plus the derivative of 1. This is the derivative of x squared minus the derivative of 7,386.2957001. Repeating. Well, what do 1 and this giant ugly number have in common? Well, they're both constants. So the derivative of any constant is 0. So this is the derivative of x squared plus 0, 2x. This is the derivative of x squared plus 0, 2x. So the derivative of anything plus a constant, so we can say, we could work this out literally an infinite number of times and get the exact same answer, and it'd just be a waste. So we can just say x squared plus or minus c, any constant, prime, is just 2x. So we know that the derivative of any function plus c is unchanged. So we have to add plus c to any function we're taking the indefinite integral of or the antiderivative of, because we could have any function, any constant we wanted tacked on to the end of this, and it would totally be cool, and the derivative, the antiderivative, would be exactly the same bloody thing, because we'd just be adding 0 to it. So that's why we have to have this big fat plus c right here. So let's just quickly go ahead and let's make this c smaller and simplify this down a little bit. Plus c. Okay, great. Now let's simplify this. We're just going to end up getting, let's see, x plus x squared minus x to the 4th plus c. All right, so that's all we're going to end up with. So this right here is our antiderivative, and we're done. This is our indefinite integral. So just a really fast recap of what we did, because this isn't really that hard. It's just, you know, slightly labor-intensive sometimes. Indefinite integrals, we're taking a function and we're taking its antiderivative, getting another function that is, when you take the derivative of this function, you get this function right here. That's all this is saying. So that's the antiderivative, and we broke this up into 3 separate pieces. We didn't want to work with this big ugly thing, so we broke it up into integral 1, integral 2, and integral 3 here. And then we just evaluated each of these independently. We evaluated everything separately, and we got separate answers, and then we tacked that c onto the end because of the reason we discussed right here. And I think I really need some serious help with my overuse of this highlighter, so I apologize for that. That's just terrible looking. But all right, we're done. This is our final answer right here. X plus x squared minus x to the 4th plus any constant is the antiderivative, or the indefinite integral of 1 plus 2x minus 4x cubed dx.